An air intake is the point from which the engine is supplied with air. This air is usually drawn through a filter first. More enclosed intakes will restrict airflow and thus make a little less power. On the other hand, they are quieter and will make the engine more reliable with reduced service costs. The race intake will dramatically decrease the engine's service life, but it will both sound fantastic and not restrict airflow. Fuel mixture adjusts the average air-fuel ratio the engine is using. A ratio of 14.7 parts of air to 1 part of fuel is known as the stoichiometric mixture, STOIC for short. This is the ideal ratio at which there is the exact amount of air to fully combust all of the fuel. A mixture with more fuel than STOIC is known as rich. A rich mixture can produce more power and burns cooler, so is less likely to knock. However, tends to produce more emissions as some of the fuel remains unburnt. The opposite of this is a lean mixture where there is less fuel than STOIC. This is great for economy, but has the opposite effects to a rich mixture. Therefore, a lean mixture will produce less power and burn hotter, so is more likely to knock. Ignition timing refers to when the spark plug fires relative to the position of the piston. As it takes some time for the spark to set off combustion, the spark must be fired before the piston reaches the top of the cylinder, thus causing the highest combustion pressure to occur when the piston reaches the top. The faster the engine spins, the earlier the spark needs to be. The earlier the spark happens, the more advanced the ignition timing is said to be. More advanced timing usually allows you to extract more power from combustion, making for a more efficient engine. but can cause knock in high compression engines running low octane fuel. The later the spark happens is known as retarded timing. Retarded timing will reduce power, but can allow an engine to run on poor quality fuel. The RPM limiter restricts the maximum RPM the engine can reach either by a fuel cut or a spark cut. A lower RPM limit will lessen wear, giving your engine a longer lifetime. A higher RPM allows the engine to reach higher speeds, allowing it to make more power at the expense of the engine's lifespan. If you over-rev an engine too much, it will shorten its life, or at worst, cause it to throw its internal components out the side of the block.